Alright, time for another draftphysics.com, debatephysics.com, also a video presentation. So we did find one person that will admit that they believe that it actually does take 100 times the energy to spin a motor 10 times as fast. Now, unfortunately, we don't have any evidence one way or the other, but yeah, okay. I'll laugh at that. Yeah, okay. Ridiculous. Doesn't happen. There probably is evidence. It's just finding it, where somebody does an experiment and there's obviously not, 100 times the watts going into the experiment. They're measuring it on a meter and they're spinning something. And so there's probably lots of inadvertent evidence. There just isn't any that we can link to. Unfortunately, that's done for the scientific purpose of proving the point one way or another, because science doesn't prove anything. It doesn't really like evidence much. And that's just the truth. Physics, evidence. It's all about just playing with the fun ideas. And so when they're less than brilliant, I would argue, fun ideas, is the simple Newton's cradle kind of thing, and then what they say happens when I start changing things just subtly. So you swing something in, and you say it has 100 momentums, it bangs into the other object, this one stops, this one goes, and you get your 100, and it's all, whether it's joules, whether I'm doing kinetic energy or I'm doing momentum, it's all conserved because they're the same mass, and so there's no problem. And then eventually, they're going to take that simple idea, 100 in, 100 out, and we're going to end up with, 200. Well, we're going to end up with 200. 200 going this way. Somehow we're going to start with 100, and we're going to end up with 200 going that way. So I guess I'll draw it this way. So we're just going to put 100 in, and we're going to get 200 that way, and we're going to get 100 back this way. So we're going to have a grand total of 300, masses moving with velocity. We're going to have 300 worth. So we start with 100 and we'll end up with 300. So we will more than double, you could argue, clearly more than double, the amount of energy we're going to get out of something this simple. Probably should use a darker pen. Let's try this one. See if it's any better. Yeah. All right. So how do you, incrementally I add a little bit of mass to this thing, and I start increasing the amount. So I have zero reflection in this case, So I add a little bit of mass, and I'll get more energy. So I'll get like 110. And whatever I got in more energy, I'll also get back as a reflection. So I'll get 10 coming this way, right? And so then if I make this 130, try to get through it quickly, and I'll end up with, so I made it a little bit heavier, just keep making it a little heavier, and I keep getting more momentum. So that's their theory. And now I get 30 as a reflection. So I keep getting more reflection the more energy I put in. So the more energy I give this object, the more energy I get back, frankly, to do it again and again and again. And I can keep making all this extra free energy. This is their theory. I'm sorry. It really is this silly. So when I get to, let's say I'm going to double it. So now I'm up to 200. Well, let's say, 33 would be the number here. So this would be a good one to put 33, because, that's twice the mass. So when I've gotten to twice as big, this is 2x the mass now. And if I get to 3 times the mass, so now I've really increased the mass of this object. It's 3 times bigger than it originally was. And now I get 150 for free. And I get 50 back this way. All right. This is their theory. So I get an extra 150, so it's real momentum. They don't think momentum is energy, I guess. They don't think momentum knocks things over or pushes things. But I do think it does. And so, it doesn't make much sense. All right, now I don't know if I've done any calculating to get these numbers exactly right, but the next progression you could say would be 175, somewhere around that number. And that would be a 4 mass. So this is all energy, extra energy going this way. So I got an extra 75 this way and 75 this way. Extra, that is, besides the 100 momentums. And then eventually, when I get to like a 5 mass, we would assume we're getting close to 200. So it's close to this number. Now, no one's done this experiment. So until we see it done, you can't really say for sure. Okay. But I'm going to get a full reflection back. So that's when I get my full 300. And so this is what their physics says actually happens. That somehow I can double the momentum by creating less movement. So less I can... Well, see, that doesn't make sense. I mean, it's not less movement because it's a heavy object. So, it just doesn't make any sense. And clearly what happens, which you do see, is that if you have an anvil, well, you could understand it as any surface. And, I had a rubber ball and I bounced it off of a surface, a brick wall. That I get let's just say it's a super ball. I get a very good reflection. Well, the more I let this surface yield, the more it moves, we know it doesn't reflect that much, So it does diminish the reflection the more this object moves. And it just makes sense that obviously what's really happening is the more you kill the reflection, the more energy went into the thing. And so the faster I move this object, the less bounce back I'm going to get. The more it yields, the more easily it moves. And, they sort of prove that with an anvil, where you can drop a ball on a dull anvil that dents a little bit and it'll bounce a few times and that's it. But if you make it really hard, steel, and you make your object out of the right material, it can bounce a couple of hundred times, so it can bounce 200 times. And obviously by this theory, I've put 200 times, 100 or 200, I've made it a tremendous amount of energy I've put into the anvil because it just keeps bouncing, keeps doing the same thing over and over again. And it's real energy going backwards, obviously. It has to defeat gravity, and then gravity pushes it back in. So this is obviously real energy going backwards. It's not some sort of unenergy. So anyway, it just doesn't make any sense. Clearly what happens is the more this one moves, the less this one is going to reflect. And the less it moves, the more it reflects. Simple. And it can only have 100. That's what you started with. That's all you can ever have in the system is 100 momentums. You have to conserve the momentum. All right. So we'll move along to a comment. Yeah. Okay. Where the concession is made that they do, I guess some of them might be willing to admit that they believe absolutely silly things. And, so that's good. At least that's more honest than the rest of them have been. So I shall pause. Alright, so here's the comment by some fool who I asked to answer the questions, and he did. So that's some sort of progress. Does it take 100 times the energy to move a motor 10 times as faster? Answer, yes, if there is no wasted energy. Okay. Since faster objects lose more energy to friction, which is just hilarious. They lose less to friction with a surface, but whatever. Engines create more sound and heat when they run faster. Says you. They create higher frequencies that you don't hear. That's what they do. But whatever. I guess it takes more than 100 times the energy to spin a motor 10 times as fast in reality. I guess it takes more than 100 times. So he's actually saying that. So, race car drivers have never noticed this insane amount of fuel loss, and you could just use that everyday people haven't noticed this, that, it's like they have a hole in their gas tank when they go 50 miles an hour. So I just say, silly answer, frankly. He's just saying, well, I haven't got any choice. If I'm going to believe in this silly theory, I have to say something that's really stupid. So he's going to concede something really stupid. All right. Let's see. Why does a pair of light bullets get more energy from the same explosion than a pair of heavy bullets? And by energy, he means kinetic energy. Okay, so let's draw it real quick. It's been done over and over, but we'll do it one more time. Okay, so here's the simple example. You put 2 light bullets. So these bullets weigh 1,000 times less than these bullets. You have exactly the same explosion. Theoretically, again, we don't have these experiments, but the fact is that guns do work. So the argument would be is that you have to conserve the energy, quote unquote. So the momentum is conserved with these numbers. Let's just understand. So if I say that yes, these bullets will leave with 4,000 joules, they'll leave with 1,000 times the velocity that these will leave with. Okay, and so the momentum's conserved. They have all of 4 bullets have the same energy, velocity, and mass ratios, products. Okay, and it's just this kinetic energy thing that's way off. I mean, just way 4,000 joules to 4 joules would be the, if you were going to use this as an experiment to see how much energy the explosive had. In one experiment it's going to say 4 joules, and the other experiment it's going to say 4,000 joules. So it's the same thing as saying 4 watts and 4,000 watts. So obviously no conservation there. Now to make it conserve the kinetic energy, you have to say that these heavier bullets only leave with 33 times the velocity of the heavy ones. That's it. They're only 33 times faster, not 1,000 times faster, only 33 times faster. To bring their joule number, okay, to something, close to the other bullets. So yes, that's just absolute nonsense. The 1,000 times lighter, it's going to go a lot more than 33 times faster. So that just doesn't work at all. But there's no evidence that this isn't true. So I guess until he provides some explanation for how it's possible that the gun doesn't work, that is, it's not able to shoot the bullet at the same speed because I put another bullet on the other side. Instead of having a gun here, okay, I put a bullet here. That somehow he has some evidence that that completely destroys the ability of this bullet to fly, when no, it doesn't. All right, so that's the background for his comment. Which is, all right, why does a pair of light bullets get more energy from the same explosion than a pair of heavy bullets? Answer, obviously that doesn't happen. Well, I think it obviously does happen, so fuck you, right? There's not much point in talking, right? Because you think it does take 100 times the fuel, and there's just no evidence. There's no reason for me to believe that. And there's certainly no reason for me to believe that you can't shoot this light bullet 1,000 times faster. That it won't happen in real life. Okay. Obviously that doesn't happen, says you. Some explosions, same energy. Well, I mean, to make the energy numbers match, I have to make the bullet go, I don't know, 33 into 1,000. I have to make it go, whatever, 17 times slower than it should be going, or whatever. Let's see. You are confused because a lighter bullet gets disproportional amount of energy. How does it do that? And was there any evidence that it gets disproportionate? The gun proves the case. I mean, the gun is showing you the bullet flying out with 1,000 times more energy than the gun's recoil, completely violating Newton's third law. So, I mean, why do you bother with talking about Newton's third law when you don't believe in it? If it is paired with a heavy bullet or gun. So says you. So show me the physicist who says that's true. That somehow the bullet is actually deriving more energy from the explosive than the gun is. Because again, that's not consistent with equal and opposite reactions in any way. So I say, fuck you. Yeah. Let's see. So you argue that it takes twice the time to stop an object twice as fast using the same resistance. So this is just playing games with words. So he's he's going to say the same resistance over distance, and I'm saying the same resistance over time. And those obviously aren't the same thing. So, it's just a word game he's playing. Now, I've drawn falling objects and rolling objects so many times, and I'm not going to do that again. But anyway, for example, an ideal case is a bullet penetrating clay. I don't know why that's ideal, but whatever. Then you must understand that twice the, again, the whole idea that the force that you're collecting, that is, you're taking the bullet's energy, and there's only two ways. You can either lose some of it by pushing clay in the wrong direction, or you're pushing clay in the right direction. Those are your only two options, and the idea is to collect the energy in the right direction. But anyway, then you must understand that twice the average velocity with twice the travel time means 4 times the distance. The fact that it's 4 times the distance is clearly a statement where I'm conceding it goes 4 times the far. It doesn't mean it did 4 times the work. That's the point. The point is you're saying the ground is 4 times heavier. So I really can't avoid drawing it, so I'll draw it. Okay, so really very simple. Okay, so I'm going to roll 2 things, one with twice the velocity. It's going to roll 4 times the distance, and my simple argument is it doesn't do anything close to 4 times the work. So there's not 4 times the energy inside of it, because the ground will not get 4 times as hot. It'll only get twice as hot. Twice as hot. And this sort of proves it right here. So this is what 1 velocity does. Okay, so we can see what having 1v does right here. And we know that's what this is doing right here. Okay, this is 1v experiment right here. So this experiment is exactly the same as this experiment. Okay, we know that. So right there you're in big trouble because you're going half the speed 3/4 of the way down the track. So obviously this isn't some sort of average velocity thing or some sort of average, the average velocity would end up being much higher than the actual average of the application of the force, because the force is time dependent. 1 second, 1 second, 1 second. So these are all facts. This takes 1 second, let's say 1 unit of time. This takes 1 unit of time. And this takes 1 unit of time. There's only 2 units of time for this to go 4 times the distance. So in 2 units of time, it only extracted 2 units of energy. It only applied 2 units of counter force. And that's the fact. Okay, and that's true in gravity. So it doesn't matter whether I do this going up or whether I do this falling down in gravity. It doesn't matter. It's always the same Galilean thing. So I've been over this and over this. It's only 2 units of time to go up to here at twice the velocity. That's all, not 4 units of time. Didn't take you 4 units of time. All right. So clearly saying something like average velocity, well, I'm not talking about an average velocity, because we know the average is already messed up because we're going half the speed 3/4 of the way down the track. So the average by distance wouldn't be right. It's the average by time. The force applied by time. And it's just kind of obvious. So your contention that this has 4 times the heat, that's what you're agreeing that that's what you believe. You believe this ground, all the energy was absorbed. Let's understand, this ball stops here. This one stops here. Stops. All the energy has been extracted, and the only place the energy is, let's just ignore air resistance, the only place the energy could be is in this ground. Okay, and you're saying it's 4 times hotter than this ground. And I'm saying, nope, it's only twice as hot. Because it's only had twice the energy and only extracted twice as much energy. And that, I think, is indestructible. So show me somebody explaining where I made an error there, okay, that you can prove to be an error. That you have some experimental evidence demonstrating that anything I just said is wrong. So until you show me an experiment that shows what I just said to be wrong, you lose. Yeah, okay. All right. So, all right. Then you must understand that twice the average velocity. So this is average velocity measured by what? Time, or measured by rolling distance. The whole argument is that it's constantly changing its velocity. And that the average velocity, if you go by distance, will be much higher okay, than, showing you the correct proportions. The average is going to be here in the middle, not here where the actual half is. Okay. The average, so we threw the word average in here, like I said, which had nothing to do with the conversation. Okay, with twice the travel time means 4 times the distance. You are a Leibnizian. So, no, I'm not, and you are. And why are you embarrassed to say you are? So just admit that that's what you are. You thought Newton was wrong, and you think Leibniz was right. So why can't you just honestly say that's how you see the world? Newton, even though he did all these frickin' experiments, was completely misguided and got it all wrong. And he didn't realize that all his correct calculations and correct predictions were just happy accidents because his theory was fucked up. Yeah, so he got wrong answers. You got right answers with the wrong theory. That's your statement. My statement is, no, it's you people, it's you Leibnizians who will crash if you try to land on the moon because you don't understand what energy is. All right, as you know, objects falling in gravity gain 19.6 meters of velocity every 2 seconds. Yeah, so I don't know why he said it that way, but fine. So we get so this is where he just shows what a faker and phony he is. So we got 19 meters per second divided by 2 seconds. So why didn't he say 9.8 divided by 1 second? Yeah, okay. And then he says that equals 19.6 divided by 2 meters per second per second. Nobody does that. If I multiply 5 pounds times 6 pounds, I don't say pounds squared. And the same is true for kilograms or kilometers or anything. I just multiply the digits and I just carry the sign. I don't sit there and say every single time I add another exponent, every time I want to add 6 numbers, for example, that then I would say it was seconds 6 to the 6th power. I wouldn't do that. They just multiply the 2 numbers and it's still meters. It's not some new thing. All right. So this seconds divided by seconds, okay, is the bullshit. That's 0. Okay. Those are the same numbers. That calculates to 0. So anyway, as a unit, so it's just bullshit. It's clearly 9.8 meters per 1 second. That's Newton's formula. This is not Newton's physics. It's not even Leibniz's physics, frankly. But whatever. It's just bullshit. There's no ratio that is to a squared function, and especially one where there's no geometry for a squared second. It's 9.8 meters per 1 unit of time. That's Newton's statement. He didn't even put it in seconds. He just said time. Okay, the unit of time, a unit of time. All right, see, we did not square any numbers here. Well, you obviously did. So anyway, and if you claim the second is squared to justify the squared velocity in KE, please show us how you get from a squared second to a squared velocity. Well, you have it right here. So I'm just saying that you have a squared second right here in 9.8. So any velocity I calculate based on this formula with a squared second, and it's going to give me a squared velocity. So I don't see how you avoid that. So frankly, I don't understand how you think this squared second just doesn't hurt anybody, doesn't cause any trouble or mayhem. Nonsense. If it doesn't do anything, why do you have it there? Why don't you just get rid of it and say it equals 9.8 meters per 1 second? Because that's the actual ratio. It's not any number of seconds, and it's not seconds squared. It's 9.8 meters per a number of seconds. And it's not division anymore, it's multiplication. It's mass times velocity. I don't know. So whatever. Yeah, so enough said. But at least he answered the questions. And again, the statement to you is can't you see that there's really no room for disagreement here? I mean, you're going to there's some guy who's trying to defend the Shroud of Turin as, there's new evidence that, what are you talking about? Jesus was, 8 feet tall. I don't think there's any new evidence. Anyway, it's just, the whole thing is just so ridiculous. Anyway, where are we? Yeah, so whatever. Go ahead. My argument to you is why don't you just make yourself a channel to say this wacky crap? Why you bothering? I mean, because I'm not going to keep arguing points we've already argued. So we've already argued it. You're saying you believe it in spite of the fact that you don't have any evidence for it. I would say, okay, I have the Mythbusters car crashes, so I'll just go with that. All right, when they crashed cars into a brick wall, there was no evidence of this extra kinetic energy. Okay, it didn't show up anywhere, so I'll just say, there, I'm convinced, good enough for me. And until you can show up with a piece of evidence that, 10 times the rotations in a motor requires 100 times the energy, we really don't have anything to discuss. Okay. I mean, it's just such a fundamental disagreement that there's nowhere to go from there. And again, you saying that bullets don't come out of guns if I don't have something behind, if there isn't a solid object for the bullet to push against. I mean, sort of the whole argument about thrust is that it doesn't need a ground to push against. It just gets in the way. I mean, NASA sort of says, we don't need the ground to push off of. We don't need the atmosphere to push off of. That's not the idea. So in a sense, you're disputing what NASA says about reality. And a bullet doesn't need to push off of something else. The explosion has the energy. The explosion sends energy in both directions, and you can't undo the energy it sent. And there's not enough time for a reflection, basically. All right, so that's enough. So till the next time and such. This has been draftphysics.com. I am, Google is such a. Anyway, so I've done this thing where you can monitor your website through Google in terms of its search, and they're conceding they index none of my pages on my website. But they don't give any reason, and they only tell me the pages they don't index. They don't tell me there's no pages they do index, and they tell me, well, these are the ones that don't index, and the reasons are all bullshit. Like somehow they went to the page when the server was down or something, and they say there's no page there, so of course there is. So but even when I correct those, right, so they have like 30 pages that aren't 30 video pages. There's like thousands of those. And there's 30 that they can't index for some reason. So I had them re-index them, and they still don't show up on the index column. So there's still no pages on the index column, which it's just bullshit. I mean, it just is absolute bullshit that you have a website and you can't get on the internet because Google decides whether you're on the internet or not, and they decide they don't like you and you're not on the internet. I mean, it's not how the internet's supposed to work. But no one cares. They just don't care that they're letting Google feed them reality. And really bad idea.